Alright, welcome back folks. In this video we're going to use ratios to solve proportions. Okay, so first of all, what is a proportion? Well, a proportion is when we have two situations, two scenarios, which satisfy the same ratio. Meaning, in both situations we're comparing the same quantities, right? Apples to oranges, or one color car to another color car, or one type of animal to another type of animal. And we're doing the same thing in two separate environments. And we say that they have the same ratio. They have the same ratio, meaning the same comparison of those two items and the same kind of numbers that correspond there. Okay? Remember, we're working with fractional values, so we're talking about equivalent fractions here. That whole thing is called a proportion, right? Solving proportions is finding the fractional values that are proportional to one another. Let's take a look at how we can do that. So here is an example. In Carl's parking garage, there are 16 white cars and 20 blue cars. In Sarah's parking garage, there is the same ratio of blue cars to white cars. If there are 80 white cars in Sarah's parking garage, how many blue cars are there in her garage as well? So, this is exactly what I was describing before, right? We have two separate environments, Carl's parking garage and Sarah's parking garage, but they both have the same ratio of two different color cars. Okay, this is a fairly common experience, right? We've got one situation over here and another one over there that are similar to one another. Now, each of these has a ratio of white cars to blue cars or blue cars to white cars in their individual garages, but we're saying that these are equivalent. We want to express them as fractions, each ratio as a fraction, and make them equivalent to one another so we can find the missing value. So first thing is first, let's take a look at the garage that Carl has, and we want to look at the ratio of the cars in his garage. Now, specifically, what ratio are we looking for? We are looking for the ratio of blue cars to white cars. Blue cars to white cars. So the number of blue cars in Carl's garage is 20. So for Carl, let's make his name red here. So for Carl, the number of blue cars is 20 compared to the number of white cars, which I'm going to do in green, which is 16. So we're writing it as a fraction, 20 over 16. Now we are saying it is the same as the ratio in Sarah's garage. Okay? So now let's set up the ratio for Sarah's garage. So for Sarah, we know that she has 80 white cars, and we're trying to find how many blue cars there are. Remember, the ratio is blue cars to white cars. Blue to white, which means it's blue over white. We do not know how many blue cars Sarah has, right? That's what we're trying to find. But we do know she has 80 white cars. Now take a look at what we have here. We have two fractions, one of which is missing a numerator. And what do we use in place of numbers that we don't know yet? We use variables, right? So we're going to put a variable, let's call it x. Let's put x on top there. X is the value we do not yet know. And we know that these ratios are the same, which means they are equal to one another. So we set up two ratios, and we've equated them to one another. This is proportions. This right here, this is, if you took a screenshot of this, this is proportions. Now we need to solve this proportion. How do we do that? Well, we can kind of think and logic our way through it if we wanted to. We could look at this. We know they're equivalent fractions. So what would I have to multiply 16 by to make 80? Well, we'd have to multiply by 5, right? 16 times 5 is 80. Well, then if I were to multiply the bottom by 5, I'd also have to multiply the top by 5, and I would see that x is equal to 100. Now, that's kind of a hand-wavy way to do it. We don't need to do it that way every single time. In fact, there's a method that we can use to solve for this, okay? And it actually uses our algebra skills to do so. And this method is called cross-multiplication. Now, I do not want you to confuse this with fraction multiplication, okay? Because a lot of people do this. A lot of people say cross-multiplication and fraction multiplication, oh, they're the same thing. They're not. Cross-multiplication says what we're doing is we're going to take the denominator of one fraction, the 80, and multiply it by the numerator of the other. We would do 20 times 80. And then what we do is we do the denominator of the other fraction and multiply it by the numerator of the other fraction. So 16, which is the denominator of Carl's fraction, times x, which is the numerator of Sarah's. So let's do that down here. So I've got 20 over 16 is equal to x over 80. So cross multiplication, I'm going to multiply 80 times 20, which is 1600. This is equal to 16 times x, which is 16x. Notice now they're on each side, right? Because I'm bringing the 80 up to the other side and multiplying, and I'm bringing the 16 up to the other side by multiplying. Okay? It's just two algebraic steps combined into one. Now I have 1600 is equal to 16x. How do I solve for x here? One step, right? Divide each side by 16. I divide each side by 16. The 16s on the right go away. I get x by itself is equal to 100. So what does this mean? There are 100 blue cars in Sarah's garage. There are 100 blue cars in Sarah's garage. That's what we found. And we were able to do that using proportions. Check back in for more examples, guys. I'll see you next time.